So we're going to start chapter 11b with section 11.4, and we're going to talk about inscribed angles. An inscribed angle, which is different than a central angle, is an angle whose vertex actually sits on the circle and whose sides contain the chords of the circle. So I've got chord AC and chord TA, and those are actually the sides for my angle, whereas my vertex A sits on my circle. So the inscribed angle that I'm working with is angle CAT, and it forms an arc, and that arc is arc CT. So the intercepted arc is what we call it, is the arc that's formed by my inscribed angle. This leads us to a theorem, and the theorem says that if you're working with an inscribed angle in our circle, then the measure of the angle is actually going to be half the measure of the intercepted arc. So if the vertex of my angle sits on the circle, then the angle is going to be half of the arc, or we would say that the arc is going to be twice the angle. So for our example here, we know that if this angle, or this arc, is 60 degrees, my angle should be 30 degrees. So let's apply that theorem. If I have angle JKL, and we know that this angle is an inscribed angle because it sits on the circle, the angle itself is going to be half the measure of the arc. Well, this arc currently isn't labeled, but I do know one thing. I know that JK is going to be a diameter of my circle, meaning that this whole arc here is actually a semicircle, and there's 180 degrees in a semicircle. So we know that arc JL is going to be 80 degrees. If the arc is 80, then the angle is half of that. So that means that X is going to be 40 degrees for my angle. In the next one, we know that my angle is 75. So if I know that my angle is 75 degrees and it's sitting on the circle, the arc is going to be twice my angle. So if I take my angle and I double it, I know that X is going to be 150 degrees. So what happens when I've got two inscribed angles and they end up forming the same arc? So if I take a look, I've got angle 1, and we see that it forms arc AB, and I've got angle 2, and it forms arc AB. If my two angles end up forming the same arc, I know that the two angles then must be congruent. Why? Because look at this one. If I have an arc and it's 68 degrees, that means angle 1 would have to be 34 degrees. That same exact thing has to occur for the angle 2, because if the arc that's formed by my angle 2 is 68 degrees, that means my angle has to be 34 degrees. So anytime two inscribed angles of a circle or congruent circles intercept the congruent arcs or the same arc, then we know those angles have to be congruent. Another theorem that we're going to cover talks about an inscribed angle of a circle and the inscribed angle if it forms a semicircle. If this inscribed angle forms a semicircle, we all know that semicircles have 180 degrees for the arc. If it forms a semicircle, the angle is actually going to be half of that arc. So it makes sense that the angle should be a 90-degree angle. Now let's go ahead and apply that last theorem. If we take a look at this one, I want to figure out what the measurement for A is. So I want to figure out what the value for A is. And I notice that this inscribed angle actually forms a semicircle. So if it forms a 180-degree arc, the angle itself has to be 90 degrees. So I'm going to say that 5A plus 20 is going to equal 90. And then all you do is just solve it from there. So 5A is going to equal 70 after we subtract my 20. And then when we divide by 5, we're going to end up getting 14. The last theorem that we'll cover in this section of notes talks about taking a quadrilateral and inscribing a quadrilateral in a circle. So right here I've got a four-sided figure, a quadrilateral, and I've put it so that each vertex of the quadrilateral sits on the circle itself. So we call it an inscribed quadrilateral. As soon as I know I'm working with an inscribed quadrilateral, then I automatically know that the angles that are opposite of each other have to be supplementary. And it makes sense because if I take a look at angle 1, that's going to form this entire arc here. And angle 2 is going to form the entire arc over here. So if I add all of that up, I get 360 degrees. But we know the relationship from an arc to the inscribed angle should be half. So it makes sense that if I took 360 and divided by 2, we would end up getting 180. So opposite angles in an inscribed quadrilateral are going to be supplementary. So the measure of angle 1 plus the measure of angle 2 will have to equal 180 degrees. If we use that information and we apply it in the example down below, what I would like for you to do is try to figure out what the measure of angle Q and the measure of angle R are, write them down, pause the video. Once you've got your answers written down, start it up again, and we'll see if our answers match. So to find the measure of angle Q, I took a look at what the opposite angle was, and the opposite angle to angle Q was S. So since S was 100 degrees, I know that supplementary, they'd have to add up to 180, so angle Q was 80 degrees. If I took a look at the next one, angle T was 95, so its opposite angle of R, they had to add up to 180 degrees, so angle R was 85 degrees. For our last example here, we're going to apply that last theorem again. It's one that says if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. What I would like for you to do is I'd like for you to try to solve and find out what all the angle measurements are of the quadrilateral GHJK. Go ahead and do that for me now. Pause the video, and then when you've got all of your answers written down, start it up again, and I'll show you, I'll run through my work also. Alright, so hopefully when you take a look at this, you ended up getting B to be 15, J to be 110, G to be 75, K to be 81, and H to be 99. So if I take a closer look, I realize that J and G were opposite angles in the quadrilateral, and since it's inscribed in my circle, I know that they're supplementary. So we added them and we set them equal to 180. That's how I solved for the B of 15. Once I got the 15, I took that and I plugged it in for my angle J. So I got 110 for my angle J, and then I realized angle G, if I plug it in, I biffed it a little bit. Let me change this up. Not 75. That's actually going to be 70 degrees. That didn't make sense. Here we go. So 3 times the 15 plus the 25 gives me 70. And a good check, what I just looked at was I saw that J and G, they were supposed to be supplementary. So if I had 110 for angle J and I had 75 for G, that didn't make sense. So if I double check, yep, all right, so angle G should be 70. Then for angle K, I ended up plugging the 15 in for my B, and I got 81. And since K and H are opposite, then I know H should be supplementary with K. So therefore, H should be 99 degrees. Make sure that if you have any questions, you ask your teacher in class. Otherwise, have a great night.